So today we're just going to look at solving mixed resistor circuits. We're going to apply what we did last lesson. How are we going to do that? Well, most circuits have some series and some parallel parts. To solve them, we need to first of all recognize which sections are in series and which sections are in parallel. Then we're going to simplify the circuit to find the total equivalent resistance. I usually abbreviate that R total. And once I know R total, I can go V total equals I total, R total. I can find total current because I'll almost always know the chairlift. And then use Kirchhoff's rules to find the rest of the unknowns. For example, example 1 says identify resistors that are in series or in parallel. Let's call this resistor 1, resistor 2, resistor 3. Which resistors are in parallel? 1 and 2 are not in parallel. 2 and 3 are in parallel. 1 is in series with whatever the mathematical equivalent of this is. So let's just stick some numbers on here. Supposing I told you that this was 6 ohms, 5 ohms, and 4 ohms. Just making up numbers. And because I made these numbers up, the odds are very good that my answers will end up being yucky decimals. Okay, what's the total resistance of this circuit? Well, first what I would do is I would replace these two with a single equivalent resistor. I might go over here quickly. Oh, that's right, Mr. Dueck. And say, okay, I got a 6. Replace these two with their mathematical equivalent. How? Well, 1 over the resistance, because they're in parallel, is going to be 1 over 5 plus 1 over 4. So on my calculator, 1 over 5 plus 1 over 4, 1 over 5 plus 1 over 4, reciprocal of that. And those of you that have the TIs, by the way, if you go math, enter, it'll give it to you as a fraction if you want an answer that's not rounded off. Anyways, I'll use 2.22. So these two are the same as a 2.2 ohm resistor. Hey, what is the total resistance of this circuit, Matt? Because what's the rule now that these are in series? Don't reach for your calculator. What do I do with those now? Oh, sorry, I thought you were with me. I just add them up, right? In series, we just add them up. Okay? Some of you need to do the homework. Total resistance of that circuit is 8.22 ohms. Now, if I knew the total battery, I could find the total current. I could solve everything. What about this second one? Again, let's call this R1, R2, R3, R4, and R5. Can you tell me 3 resistors that are in series with each other? Yeah. Sorry? R1 is not technically in series with R3 because all of the skiers current that go through R1 do not have to go through R3. Don't they have another path? So they're not. These 3 are in series with each other. And if I replace these 3 with one mathematical equivalent by just like adding them together, then R2 would be in series with whatever in parallel with whatever the mathematical equivalent of this was. Hey, let's put some numbers on here. How about let's go 10 ohms. Let's go 3 ohms, 2 ohms, 2 ohms, 2 ohms. And if I said to you, okay, let's find the total resistance. First of all, I would mathematically maybe redraw it like this. Now, if you get good at this, you actually don't need to completely redraw the diagrams, but until you get good, I will almost always give you lots of room. So I'm going to go boom, boom. I got a 10, and you'll notice I'm doing a really sloppy diagram. Sometimes I'm not even putting the resistor symbol in. I'm just putting the number there. Okay, I got a 3 going this way. If I wanted to replace these 3 with one resistor, what would that be? A 6. Okay, these 2 are in parallel. What's the equivalent of that? Well, that's going to be... My abbreviation for R parallel, by the way, look up, because that's the geometry symbol for parallel lines. So if you're ever looking for abbreviations, 1 over R parallel equals 1 over 3 plus 1 over 6. So I'm going to go 1 over 3 plus 1 over 6. Take the reciprocal of that. Conveniently, that one did work out evenly. What are these two the same as if I combine them, Katie? So if I'm lazy, I would probably go like this. There's my quickly rehashed circuit diagram, Trevor. And now I can clearly see what is the total resistance. 12. Those are the strategies I'm going to use. Sometimes I won't need to. Maybe I'll be able to have enough. They told me 2 things on a resistor. Again, my goal is almost always to find total current. Let's do this next one. We'll call this R1, R2, R3, R4, and R5. Can you tell me some resistors that are in parallel with each other? 2 and 3 are, so if I wanted to combine them, it'd be 1 over R2 plus 1 over R3 equals 1 over whatever, if I wanted to replace that with a single resistor. Yep. Arvinder, what others? 4 and 5, I could do the same trick. And then I would have 3 in series, add them up. R total. R1, R2, R3, R4. If I was analyzing this circuit, Mitsu, I would add those 2 together because they're in series with each other, replace them with 1. 1 over whatever those added to plus 1 over that. Reciprocal of the answer would tell me what these were the same as. Combine it with R1, Katie, and I'm good to go. I got R total. It's easier to do with an example. Example 2. It says find all voltages and currents and draw a summary diagram. Okay. Before I start combining resistors, Connor, I always try and spot, is there somewhere they've told me 2 pieces of information? Because if I can figure out the current with Kirchhoff's laws, I can save myself all that 1 over R1, 1 over R2. Sometimes I'll have to. Often I won't. Have they told me, is there any resistor where they told me 2 pieces of information, Connor? Okay, that would have been nice. So now what? Well, let's see if we can do this without doing too much redrawing. I'm going to walk over here and going to go boom, boom. 4. Kara, I'd like to replace the parallel resistors with one single one. I'd like to figure out what the heck goes there. Oh, and it's 20 volts. What's this going to be? R parallel? Well, 1 over R parallel is going to be 1 over 10 plus 1 over 15. Now, if you look up for a second, bad habit, when I see kids do this, and then they go 1 over 10 plus 1 over 15, reciprocal button, and they say the answer is 6. That is a falsehood. The answer, the R parallel is 6, but you've written 1 over R parallel here, and I always worry that kids, when they look back at this, will think they haven't reciprocaled. A good habit, once you've written that, draw an arrow, not an equal sign, and say, oh, R parallel equals 6 ohms. Because you haven't, in this equation, found R parallel. You found 1 over R parallel, and then to move straight to an equal sign, Trevor, is technically wrong, and I worry that when you look at it later, you'll say, oh, I forgot to flip it. No, no. Draw an arrow, and the arrow is you saying, I flipped it. I took the reciprocal. So this is 6. Trev, what's total resistance? R total is 10. Do I know any other totals? Do I know total current? Not yet. Oh! Do I know total voltage? That's going to be the chairlift, isn't it? So what's total current? What's the equation that has V, I, and R in it? Oh, V equals I times R. So I equals, Nicole, what? What over what? So specifically in this example, what over what? Specifically in this example, what over what? Numbers. Okay. V total over R total. I should write that in our notes. In my homework, I might even skip that step. Nicole, what divided by what? And can you please, this early in the morning, do that in your head? Now, why would this be sloppy? I would say, don't forget your sig figs now, because it did ask for the current as one of the answers, and I would probably put a box around that because it's important. And then what I always do, Sean, is I go back to the chairlift, and I almost always label it just past the chairlift. There's the total current. And I start skiing, walking my way around the circuit. Brianna, what's the current in this 4 ohm resistor? Ready? What's the current right here? What's the current right here then? Yes. 2 amps. Arvinder, do I know 2 things? Then I know 4 things. Find the resistance. Find the voltage. Don't need a calculator because V equals I times R. Could I find the power? Yeah. You know what? The wattage of this bulb would be VI 16 watts. Now, why can't I go like this now? 12 volts, 12 volts. Jacob, what did I do? Nothing to do with the ohm. How high is our chairlift? 20 volts. What did we lose going through here? Can you get back to the ground going this way? Then how high must this hill be? Oh, can you get back to the ground going this way? Well, how high must this hill be? Okay. Oh, do I now know 2? I know 3. Find the current in this resistor. Current is V over R. V over R. 12 over 10. 1.2 amps. This better be 0.8 amps. Let's double check. V over R is 12 over 15. Does that work out to 0.8? Oh, great. Oh, could I find the power there? Yeah, 12 times 1.2, 12 times 0.8. What's the power? What's the wattage in each of these resistors? 12 times 1.2 is going to be 12 plus 0.2 to 14.4? No, that's wrong. Sorry? I am right? And how about here, 12 times 0.8? 9.6? Okay. You got room at the bottom of your page here? Yes? Good, because we're at a part B. B. If we remove the 15 ohm resistor, will the 10, Mr. Dueck, ohm, type in front of you, resistor be brighter, dimmer, unchanged. Explain your answer using principles of physics. If we remove the 15 ohm resistor from this circuit, will the 10 ohm resistor be brighter, dimmer, or unchanged? These are the kind of using principles of physics questions they love and I love to ask during these. Let's see. If I remove this so that this whole circuit, this whole section is no longer there, what can you tell me about these two resistors? Are they in series or in parallel? Oh, they're in series. Okay. So then, what would the total resistance of this circuit be now? Brett, 14 ohms. What would the total current in this be now? Well, now it would be 20 volts divided by 14 ohms. Which is what? $1.43? Okay. That's the total current. So with this removed, how many amps will be leaving right here? 1.43. How many amps will be going through right here? 1.43. How many amps will be going through right here if that ski hill was shut down? So we would have this. Did I number these? I didn't. Current. Let's do this. Power is going to be VI. And let's do a little sketch of our circuit over here because I think it's going to be helpful. How big was the top resistor? Sorry? 4? And now we have a 10 ohm resistor, 20 volts. We have 1.43 amps. How many volts do we, well, you know what? I'm not interested in this one. This is also 1.43 amps. How many volts are in this resistor? If I know the current and I know the resistance, do I know the voltage drop? How many watts now is this bulb showing? What do you get? You get 20.4? How many watts was it showing earlier? 14. How many watts now? Brighter, dimmer, or unchanged? Brighter. And this is a very counterintuitive one for students because a lot of the students are... Think about what happened here. By removing a bulb, the overall current went down, not up. Okay? Hey, what about this bulb here? Is it brighter or dimmer? Well, can you go 1.43 times 4 to get the voltage times 1.43? There's the voltage, and now if I go V times I, how many watts is the top bulb now? 8.2. How many was it earlier? It's only half as bright. That bugs some kids because a lot of kids are, Mr. Dueck, wait a minute, you yanked the bulb out. If you yanked the bulb out, shouldn't there be like more brightness to go around for everybody? Turns out, no. The parallel circuit is the beneficiary because now all the skiers are going through that one bulb. It gets brighter, but the total number of skiers, not as high. Smaller current. Next page. It says, find all voltages and currents, draw a summary diagram. Okay. Take a look at this. Let's plan our attack. Do we see which ones are in series and which ones are in parallel? I think the sketch that I'm going to is going to have a 6 ohm resistor there, a 5 ohm resistor there, what can you tell me about these three here? Series or parallel? So what's this the same as mathematically? 21? 20? Is that okay so far? These two here, Joel, series or parallel? So now here's what I would do. I would go 1 over R parallel equals 1 over 5 plus 1 over 20. What can those be replaced with? This is the work I would expect to see if I was marking this, by the way. What can it be replaced with? More specific. Do the math! Where's your calculator? Get it out. Katie, what'd you get? Really? Nicole, what'd you get? And if you can't, by the way, if you can't do this, you're not passing the test. You better. This is why I'm trying to force you to do this. Yes. Sorry? 4? Anybody else? Yes? Nicole, get the 4? Nicole, look up. It's... Sorry? Yes, look up. Is it a TI? Oh, it's a scientific one? Show it to me, please. Okay. Back to my earlier point, I'm a little bit lazy. I don't want to redraw this whole thing. I think what I would do now is I would go scratch, 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 4. Can you remember, or by do it, you can figure out what we've done, Brandon? I think that's still fairly clear. Because now, what can you tell me about this 6 and this 4, series or parallel? What's the total resistance? 10. All right. Total current is total voltage divided by total resistance. It's going to be 30 divided by 10. Total current is going to be 3.0 amps. Now I'm going to start labeling my original diagram. Start coming... All right, yeah, it is 3 amps, isn't it? Yeah, okay. Start coming off the chairlift. Mitchell, what's the current right here? More importantly, what's the current right there? Ah, nice. Oh, do I know 2 things? Then Mitchell, I know 4 things. And really, I'm interested in the voltage drop right there. What's the voltage drop in this first resistor? Yeah. You didn't even need a calculator. I saw you squint. I saw your brain clench for a little bit, and then suddenly, aha! Oh, Mitchell, what would the voltage measure right here then? Think about it. How high are we right here? Ah! So, Mitch, here's my question. Can I get back to the chairlift going this way? Oh! How high must this, what must the voltage be in this resistor then? Gotta be 12. Do I know 2 things? I know 3 things. Find the current here. Current is V over R. 12 divided by 5. What's the current here? 2.4 amps. So 2.4 amps went this way. How many amps went this way? Got to be 0.6 amps. Do I know 2? I now know the voltage. What's the voltage? 0.6 times 12, 7.2 volts? Yeah? How many amps of this guy? 0.6 amps. What's the voltage in that guy? 3.6 volts. How many amps in this guy? Still 0.6 amps. What's the voltage in this guy? 1.2 volts. By the way, what should all three of these hills have? What do they have to add to in terms of a voltage? Got to add to 12. Double check. Do they? There's your built-in error check, by the way. Do they add to 12? Oh, good. Could I find the power as well? Yeah, I could go VI, VI, VI. I'm not going to bother on this one. Example 4. Oh, and you'll notice we did it with a fairly minimal amount of work. I left you lots of room, and you can use more if you need to. Example 4, what happens to the total current in this circuit as measured by the ammeter, which is placed right there properly, when the switch is closed? Increases, decreases, or no change? You know what? Why don't we find the total current before and the total current after, and actually we can answer it. Actually, instead of before and after, how about open, closed? When it's open, can you tell me the total resistance right now with this switch open? What can you tell me about the 20 and the 5? Series or parallel? Oh, series, so what's the total resistance? What's the total current? Really? V over R, yes? You guys understand we're using Ohm's law, V over R, and I'm actually not writing it all the time? Yeah? Okay. 4 amps. Okay. Let's do the same thing. Now, once this is closed, oh, what can you tell me about the 10 and the 15? They're in parallel. 1 over the parallel is 1 over 15 plus 1 over 10. 10 and the 15, 10 and the 5, that makes more sense to me. What's this? If I replace these with a single parallel resistor, what would that be? Nicole. .3, or is it 3.33333? Let's go 3.33 then, just to be a little more accurate. Oh, so if these are the same as 3.333, what can you tell me about the total resistance with the switch closed? What's our total now? Arvinder, 23.33, yes. What's the total current now? Total current now. 4.29? Oh. What's the answer, A, B, or C? When you close the switch, is there no change? The current increases, the current decreases. Emily? A, B, or C? B. There. Explained. A couple other handy things. See the two resistors that were in parallel? What's the smallest resistor that was sitting in this group here? How big is it? whenever you're finding the mathematical equivalent, the mathematical equivalent will always be smaller than your smallest resistor. In other words, I knew the answer was going to be less than 5. If I added a third one, a 2 ohm resistor, I know the total is actually going to be less than 2. I don't know what, but less than 2. If I added another resistor, and it's weird because in parallel, adding resistors actually lowers your overall resistance because you're giving the skiers more options. Even though you think, oh, I'm adding resistors, actually more hills open, more skiers can go. Homework. Number 1. 2, 3. 4 is good. 5 is good. So far it's 1, 2, 3, 4, 5. 6 is good. 7 is good. 8 is good. So I've assigned everything so far. 9, oh, acceleration, it's a nice review, but I'm going to leave it. So right now it's 1, 2, 3, 4, 5, 6, 7, 8. We're going to spend a few minutes going over your electrostatics tests.